Hello student, next group is arithmetic group. The instruction of this group performs arithmetic operations such as addition, subtraction, increment or decrement, etc. on data in registers or memory. For example, add, sub, INR, etc. Now first instruction is add R, that is add register. Using this instruction, you can add content of register to the accumulator. For example, let register D has data 35H and accumulator has data 05H. Our instruction is add D, that is register name. The content of a register added to the content of accumulator and the result is stored in accumulator. Now 35H added with 05H, that is accumulator, and this is register D. Addition is 3AH, which is stored in accumulator. This is a binary addition. Answer is 3A, and which is stored in accumulator. So this instruction add R for adding the content of a register to the accumulator. Now next instruction is add M, that is add memory content to accumulator. In this instruction, the content of accumulator are added to the content of memory location, whose address is stored in HL pair and the result is placed in accumulator. For example, HL pair contains data D000H and D000H location contains data 35H and accumulator contains data 05H. Our instruction is add M, which adds the content of memory location whose address is stored in HL pair to the accumulator and the result is stored in accumulator. Now, this data is of memory location and 05H is accumulator data. Addition of this 3A H, which is stored in accumulator. Now accumulator has data 3AH, that is addition of memory location and accumulator. And memory location D000H has no affected, that is 35H. Save data. So this instruction add memory. Next instruction is ADI data, that is add immediate to accumulator. This instruction adds the 8-bit immediate data specified in second byte of instruction, means data is directly specified in the instruction which is added to the content of accumulator. For example, accumulator has data EAH. Our instruction is ADI 15H. This is immediate data. Immediate data is added to accumulator. So addition, immediate data added to the accumulator. Result is FF, which is stored in accumulator. Now accumulator has data FFH. Next instruction is ADCR, that is add a register to accumulator with carry. This instruction adds the content of accumulator to the content of register and the content of the carry flag. Now let, for example, A has data 5F, B has data 33 and carry flag is 01. Our instruction is ADCD. A register has data 5FH, B has data 33H and our carry flag is 01. Now addition of that is 93H, which is stored in accumulator. Now after execution, data of accumulator is 93H. Now next instruction is ADCM, that is add memory content to accumulator with carry. In this instruction, the content of memory location whose address is stored in HL register pair and the content of carry flag are added to the content of accumulator, and the final result is placed in accumulator. For example, let HL pair contains data F000H and accumulator contains data 35H. Our carry flag is 00 and this FF0 contains data 05H. Our instruction is ADCM. Now after execution, means after addition of this, accumulator has data 3AH. So this instruction ADCM. Now next instruction is ACI data, that is add immediate to accumulator with carry. This instruction adds the content of accumulator to the 8-bit immediate data specified in the second byte of instruction along with the content of carry flag. Means which add content of accumulator and 8-bit immediate data and carry flag. Now let, for example, accumulator has data 05H, carry flag is 1. Our instruction is ACI 55H. This is immediate data, which is add to the accumulator and carry flag. After execution, accumulator contains data 5BH. Now next instruction is SUBR, that is subtract a register from accumulator. In this instruction, the content of a register R are subtracted from the content of accumulator and the result is placed in accumulator. For example, let accumulator has data 37H, C40. Instruction is sub C, means subtraction. Now for subtraction, for binary subtraction, we use 2's complement method or 1's complement method. First, we do 2's complement of second number and add it to the first number. After subtraction, result is F7H, which is stored to the accumulator. After execution, accumulator has data 3. Sorry, this is wrong. Accumulator has data F7H. F7 and D00 memory location. Sorry, this is also wrong. Only F7. That's it. Subtraction. Now next is SUBM, that is subtract a memory from accumulator. In this instruction, the content of a memory location whose address is stored in HL pair is subtracted from the content of accumulator and the result is placed in the accumulator. HL pair has memory address 2500H and 2500H has data 05H. Accumulator has data 07H. Instruction is SUBM. After subtraction of 05 and 07, answer is 02H. Result is 02H, which is stored to the accumulator. Now next instruction is SUI data, that is subtract immediate from accumulator. In this instruction, the 8-bit immediate data specified in the second byte of instruction is subtracted from the content of accumulator and the result is placed in accumulator. Let accumulator has data 1F. Instruction is SUI 1FH. This is immediate data 1FH. After subtraction of immediate data and accumulator, that is 1F, accumulator has data 1F and our immediate data is 1F. The result is 0, 0. After execution of this instruction, accumulator contains data 00H. Now next instruction is SBBR, that is subtract, register and borrow from accumulator. In this instruction, the content of register R and carry bit are subtracted from the contents of accumulator and the result is placed in accumulator. For example, let accumulator has data 37H, B register B has data 3F and carry flag is 01. Instruction is SBBR, that is subtract, register and borrow from accumulator. B has data 3FH, borrow +1. Now this is 40H. For subtraction, we use 2's complement of second number 11000000. Now add it to the first number, that is 37 plus complement of second number. Answer is F7. After execution of instruction, result is stored in accumulator, that is F7H. Now next instruction is SBBM, that is subtract memory content and borrow from accumulator. In this instruction, the contents of memory location whose address is stored in HL pair along with the carry bit are subtracted from the content of accumulator and the final result is placed in accumulator. For example, consider HL pair has memory address 2500 and 2500 contains data 05H. Accumulator has data 07H, carries 0. After subtraction of 05 minus 7 is 02. Our instruction is SBBM, means data in memory address subtracted from the accumulator and carry. And after execution, accumulator contains data 02H. Now next instruction is SBI data, that is subtract immediate with borrow. In this instruction, the 8-bit immediate data specified in the second byte of instruction is subtracted along with the carry bit from the content of accumulator and the result is placed in accumulator. For example, let accumulator has data 32H, carry is 1, instruction is SBI 31H. This instruction 31H is immediate data which is subtracted from the accumulator along with the carry bit. Carry bit is 1H. After execution, result is stored in accumulator, that is 0. Now next instruction is RNRR, that is increment register content by 1. In this instruction, the content of register R are incremented by 1 and the result are stored in the same place. Means using this instruction we can only increment the content of a register. Suppose a register B has data 01, we use INRB, that is increment B. After execution of this instruction, B has data 0 to H. Means using this instruction, you can only increment the data and it's stored in the same place. Next instruction is INRM, that is increment memory content by 1. This instruction increments the content of memory location whose address is stored in HL pair is incremented by 1, and again a result stored in a same place. For example, HL pair has data 2500H and 2500H address contains data 04H. Next instruction is INRM, that is increment memory. Means data in memory is incremented by 1. 04 is incremented and it contains data 05H. Now next instruction is INXRP, that is increment a register pair by 1. This instruction increments the content of a register pair RP by 1. For example, let HL pair contains data D000H. Instruction is INX, that is increment and a register pair. After execution, register pair contains data D001. If we use INX again, then this incremented to D002H. So these are increment instruction. Now decrement instruction, DCRR, that is a decrement register by 1. Yeah, very much video was.